this video is the continuation of the lecture on development of quantum theory, particularly on quantum numbers. Okay. Let's do some exercise. Let's first look at number 5 over here. Which one of the following is not a valid value for the magnetic quantum number of an electron in 5D subcell? 5D. Okay. So what do I mean by 5D? 5D means the principal energy level, n equal to 5. Okay. So what about the angular momentum? Angular momentum, the allowable one will be 0, 1, 2, 3, and 4. Okay. The next one is the magnetic quantum number over here. Okay, so when you see 5D, n equal to 5, d orbital over here, what is d? What is the L number? When L equal to 0, that is S. When L equal to 1, that is P. And when L equal to 2, that is D. So L will be equal to 2. So this is the one that we will be focusing on. Okay, when L is equal to 2, what are the allowable number, magnetic quantum numbers? That is the ML. ML should be from negative L, negative 2, all the way to 2. So it will be negative 2, negative 1, 0, 1, and 2. So these will be the allowable magnetic numbers. Okay, so let's see. Over here, A, number 2 is okay. Number 3, no good. It's out of this range. 0 is good. 1 is good, and negative 1 is good. All right, let's go for the next question. Number 6. Which of the subshell below do not exist due to the constraint upon the angular momentum quantum number? Angular momentum, that is the L. Okay, so let's look at it. Let's look at A over here. A over here, when n equal to 3. So what are the possible L? So L can be equal to 0, 1, and 2. Okay, so when L is 0, that's the S orbital. Okay, well, you can call that a subshell. Okay, over here, when L equal to 1, so that is the P orbital, and this one is the D orbital. Okay, and 3F, that is way beyond this. Okay, F, that means when L equal to 3, and it's not allowed. Okay, so this one is not good. How about, let's work on B. On B, when n is equal to 4, L can be equal to 0, 1, 2, and 3. So that means this is the S orbital, P, D, and F. So 4D is allowed. 4D means n equal to 4 and L equal to 2. So that is 4D. Okay, so this is good. 4P means n equal to 4 and L equal to 1. See, that's 4P. 4S means n equal to 4 and L equal to 0. Okay, so these are good. All right, let's see if we have more exercise. Okay, that's good. All right, let's look at problem number 7 here. An electron cannot have the quantum number. Which one it cannot have? All right, let's check. Okay, so the first one is N, the second one is L. So this one is the principal energy number. This one is the angular momentum, and ML is the magnetic quantum number. So A over here, when N equal to 2, L can be equal to 0 and 1. Okay, so it's good. And when L equal to 0, the ML can be equal to 0. Okay, when L equal to 1, then ML can be equal to -1, 0, and 1. Okay, so this one is good. 2, 0, 0, 2, 0, 0. So that is good. Okay, 2, 0, and 0. All right, let's look at the next one. 2, 1, and -1. See, 2, 1, and -1. So it's also good. Okay, so let's look at C over here. When n is equal to 2, equal to 3, over here 3, can L equal to 1? Yes, L can be equal to 0, 1, and 2. So L can be equal to 1. When L equal to 1, can ML equal to -1 over here? Let's see. When L equal to 1, it can be -1, 0, 1. Yes, so it can be -1. See, it matches. So this one is good. All right, let's look at D over here. When n is equal to 1, the possible or the allowable L will be L. The only one will be 0. Okay, because L is from 0 all the way to n minus 1. So 0 is the only one. See, we cannot have n equal to 1 and L also equal to 1. So that cannot be. Okay, so this one is the answer over here. It's not allowed to. Okay, let's look at number 8 here now. Over here, which one of the following is an incorrect substitution notation? Okay, all right, 4F. Okay, that means n equal to 4. F, well, let's look at what the allowable L is first. L can be equal to 0, 1, 2, and 3. So this is S orbital, P, D, F. For F, that's good. See, 4 and F. All right, let's look at number B. When n is equal to 2, L can be equal to 0, 1, and that's all. Okay, so 2, I can have S, and I can have P. I cannot have anything higher. So this one is not good. Okay, 3S, when n equal to 3, yes, we can have 3S, yes, we can have 2P. Okay, and if you do enough exercise, you actually can memorize that this is a 1S, so this one is 2S, then you see 3 of these things, so it's the 2P, and then you can see the 3S, and then you see 3P, and then you see 5 of this, that would be the 3D. Okay, and as for now, so let me put it this way. When n equal to a certain number, in that principal energy level, you can have maximum of 2n square electrons. Okay, for example, you might need to write this down. For example, when n is equal to 1, okay, how many electrons maximum can we have? We can have maximum of 2 electrons. Okay, so I just fill it here. When n is equal to 2, how many maximum electron can I have in that principal energy level? Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, that means I have 8 electrons. Does it work with this formula? I plug in 2 here, so 2 squared is equal to 4 multiplied by 2. Okay, so I can have 8 electrons in that energy level. Okay, so let's say on the third principal energy level, what is the maximum number of electrons? So 3 squared would be equal to 9, and then times 2, that would be 18. So when n equal to 3, maximum I can have is 18 electrons. All right. All right, so let's look at the next exercise. I'm looking at problem number 9 now. Which of the following is not a valid set of quantum numbers? Okay, let's do the similar thing. When n is equal to 2, okay, so this n equal to 2, L equal to 0, that means it's 2s, okay? So, and 0 is part of it because when L equal to 0, okay, so that is s orbital, okay, so I'm allowed to have ml, okay, ml will be equal to 0, okay, from positive L, from negative L to positive L. So this one is good, okay. So let's look at this one, B now, okay. So this is level number 2. So 2, when L is equal to 1, that means p orbital, okay. So 0 is less than this one is good, so this one is good, okay. So 3p, when L is equal to 1, the allowable one will be of ml will be from -1, 0 to positive 1. So this is good. Okay, so over here, when n equal to 1, it can be s orbital. Yes, it will be this one is not greater than this one, and it's positive 2 here. Number E, when n equal to 1, the allowable L will be equal to 0, and that's all. Okay, so you cannot have L equal to 1.